Yay! Today we finally are doing some real geometry. And you're probably thinking, I know how to do Pythagorean Theorem. They taught us a squared plus b squared equals c squared or something like that, ABC. What's the A stand for? What's the B? What's the C? So yeah, we're going to learn it the right way and hopefully know how to do it from here on out. Know that the Pythagorean Theorem can be applied to pretty much every chapter we do. So later on we'll be having trigonometry. Yep, you can learn a little trigonometry in here. Don't freak out, it's not that bad. It's not the whole course of trigonometry. And you can have Pythagorean Theorem in it. Circles can have Pythagorean Theorem. All your shapes can have Pythagorean Theorem. So it is no big deal for you to be able to spot that. And so let's look at it now. Now this little video clip was from The Wizard of Oz, where they tried to do the Pythagorean Theorem, but it won't work on this video inside of a video. So if you're in class, we'll probably watch it. But if not, you can go look it up, Pythagorean Theorem, Wizard of Oz, and they will show you the clip. So they actually got it wrong. And what the scarecrow said it because he thought he was smart. He got a brain, he got a diploma, but what he said was incorrect. So if you can find that and send me a text about what he said incorrectly, I'll give you some bonus points on something eventually. But I'll keep up with your bonus points. Don't worry, I always do. So send me a text if you get it. Figure it out. Pythagoras, this is a supposed drawing of Pythagoras, who knows, actually wrote the theorem. And that means he came up with the rule, he studied it, he prepared it, and said, hey, this works all the time. Now, did he make up the Pythagorean theorem? Technically, no. It's not like he invented it. It exists. All your math already exists. It's just somebody has to come up and figure it out and say, oh, this is going to happen every single time you do it, and make it a rule or a theorem or a postulate, and go from there. And you can learn those. That's what we've learned. There's not really any new math that's been discovered because they know a lot of it. They're figuring out some sciences, but not too much on math as much. So he figured out the sum of the square, remember square like little twos, of each leg of a right triangle is equal to the square of the hypotenuse, which sounds like a big mouthful, but you're looking at a right triangle. Pythagorean theorem can be worked and solved normally only with right triangles. Now later on we're going to use it for some other stuff that'll help distinguish between two different things, but mostly it's right triangles. So to be a right triangle, it has to have the right angle box, that little box that's in the corner of our right triangle, and you'll see that box, and that means 90 degrees. So when you know that that's 90, okay, in one of the corners, it doesn't matter what the other two angles are, okay, we don't care about them, but across from that right angle, and I want you to get in the habit of this, across from that right angle is what's called the hypotenuse. It is the longest side, and you need to identify that before you start working anything else out. When we get to trigonometry, we get to special right triangles, all kinds of stuff, you need to find that hypotenuse right off the bat. So here it is, across from the right angle. So you just say, okay, this other side over here, the legs are your other two sides, and they make up the right angle. So if you got the hypotenuse mark, you can just put an H or HY, and then the other two have got to be legs. Those can't get mixed up because they're both legs. They're just called legs on there. And the hypotenuse has to be the longest. That's the rule about it. Okay? So when you use Pythagorean theorem, you know two sides. You already know two sides. You got numbers on them. And you're going to find the third side. We're not looking for angles. So if this was like 20 degrees and I wanted to find the other angle, that has nothing to do with Pythagorean theorem. Or if I had 20 degrees and wanted you to find maybe this leg was 5 and I wanted you to find the hypotenuse, and that's all you knew. You didn't know the other leg. This is not Pythagorean theorem. Pythagorean theorem is only dealing with the sides. And so what you're going to do is what's called the Pythagorean theorem. Leg squared, the sum of the legs, is equal to the square of the square of the sum of the legs is equal to the square of the hypotenuse. So you take each leg, you square it, add it up, and it's equal to whatever the hypotenuse is squared. So remember A, B, and C? That's where they came from. They get plugged in, and that's where you get it. But I want you to remember not A squared, B squared, C squared. You remember leg squared plus leg squared equals hypotenuse squared. Because that makes sense. That tells you exactly what to put in each one. A, B, and C show up in a whole bunch of different formulas, even with areas. There's law of cosines, law of sines, they use it. So, don't get carried away with A, B, and C. Think of Pythagorean theorem as leg squared plus leg squared equals hypotenuse squared. And that's just one the ACT expects you to memorize. Alright, so let's try one here. If we have 6, 8, and x, what should we do first? Label the hypotenuse. Where is it? X. Across from the right angle, that's your hypotenuse. Now, is x always going to be the hypotenuse? No, I could put x on any of the sides. I could have a leg be x and it wouldn't matter. But across from your right angle, that's the hypotenuse. Just put it on there. Alright, so now let's think about the formula. The formula is leg squared plus leg squared equals hypotenuse squared. Let's plug in leg, and hypotenuse. Doesn't matter which leg goes where. As long as you got x for your hypotenuse, you're going to have the legs just fill in any way you want. You can have the 8 first or the 6 first. Okay? Now you can pick up your calculator if you need to, but you should know some of these by heart. 6 squared, that's not times 2. That little number is not a 2, that's a square. So 6 squared is 36, 8 squared is 64, equals x squared. Okay, exponents first. We still got some work we can do right here. Add it up, you get 100. Now, does 100 seem like it would be the length of this side if one side was 6 and the other was 8? No, you're not finished. Look at your formula. Is x by itself? No. It has a little square on there. Not a 2, a square. A square. How do you get rid of a square? What's the opposite of square? Square root. Remember square roots? Alright, so on my calculators, over on the left, there's a square root button and you hit it and hit 100 and you have it. If you're doing it on your phone, you probably have to put in the 100 first and then hit the square root. If it's like a one-line calculator, how the screen will say, okay, square root of 100, and then write it, and then it'll come out here and it'll put the answer. But if you just got a one-line calculator where you type in 100 and hit square and it only shows you one line at a time, you got to do it backwards. You got to say 100 then square root. So if you don't have that at home, it might be best to download it. And if you want one that, like what we use in class, see if there's an app for a TI. You can do any of the TI-30, whatever, but mine are TI-30X IIS, that's the solars. But if you do any kind of download of a calculator on your computer, that would probably be better, because that way you can type it in the right way. Alright, so 10. That side is 10. Is it always going to come out to a perfect number? No. A lot of times you're going to get decimals, and that's okay. And any idea what those little marks mean? See, I got a little mark right there by it. A little mark by the 8. 1 mark means feet, 10 feet. 2 marks means inches. So if I had 6 inches, that would be 2 marks on there. Learn something new every day, huh? Alright, so another one just like it. 4 and the 7 are the legs. The y is the hypotenuse. Across from the right angle. And then plug it in. Now this time, the square root of 65, you can do it a couple different ways. Now, there's an ACT way, and then there's an everyday way with the decimal. the ACT will leave it square root of 65 because it doesn't have a perfect square root. That's it. You leave it just like that. Square root of 65 would be the answer. But in everyday life, we want to know, what's it closer to? What's it almost? When you square root it in the calculator, you're going to get about 8.1, but that's been rounded off. See the little wavy bar? When you see that wavy bar, that's saying I've rounded it off to something shorter because it filled up the calculator screen, didn't it? So we're going to leave it at 8.1, but just know that when you do it on the ACT, they're not going to give you an approximate. They don't want that. They don't want anybody saying, oh, well, it was close, having any doubt. So they would just say it's the square root of 65, and they would stop right there. So when you see those, don't freak out. You can put your calculator and see that it makes that same number. So it wouldn't be if you were guessing and trying to figure out which one was the best guess, then put it in the calculator. Don't just blindly guess, but know that it can be stopped right there. All right, let's try another one. Same formula. See, notice I'm writing the formula. Leg, hypotenuse. Leg squared plus leg squared equals hypotenuse. If you write it a few times, you're going to find that you've memorized it. Boom, and you're great, okay? So, where's the hypotenuse? Across from the right angle. So, here's a right angle. What's across from it? 15 is the hypotenuse this time. T and 6 can be switched up. Doesn't matter which one goes first, but the 15 is the hypotenuse, so it's got to go out here by itself. Notice that. 15 is out there by itself. So we still square it, okay? But is this telling me, when I square the 6 and the 15, is this telling me to add those two? No, they're on different sides. So remember, this is the equation like we were working before. Can I just say plus 36? No, I got to move the 36 to the other side. Oh, that's why we did all that algebra. Okay, minus 36. You're going to be left with square root of 189. And that comes out to a decimal of 13.7. Okay? And most of the time on your worksheet, I think today, I rounded it to one decimal place. But let's say it was, it was 14.56. One decimal place means I want to keep one place after the decimal, but you still got to look at that second number and say, does that make it go up or stay the same? If it's 5 or more, it's supposed to go up. So be careful with that, or you're going to end up missing some that you really did the work right, but you just got a little bit off on your rounding. So make sure you remember about your rules. 5 or more makes it go up. What you remember. 4 or less, you leave it the same. Alright. So, then you've got some problems on the sheet that make you figure out, is it a right triangle? Now, later on when we get to triangles, I'm going to show you how to use the Pythagorean Theorem when it's not a right triangle, and you'll be able to tell, say, it's an acute triangle, or it's not acute, it's acute, or it's an obtuse, by just looking at your numbers for the Pythagorean Theorem. But right now, we just want to know, is it a right triangle or not? So if I got these three numbers, and I want to check, how do I know to put it in like this? Why did I put the 16 in right here and not over here? What's the biggest? The hypotenuse has to be the biggest. So when you're doing this set of problems like this, the biggest number has got to go out here for the hypotenuse. So you work it, and you work every little square on there. So 8 squared, 15 squared, and 16 squared. Just do it like that. Okay, each number gets squared. Finish the math. Don't just say, oh yeah, I'm done. You haven't finished this side. You got to add those two. So when you add them up, is it equal? No. So guess what? It does not, make a right triangle. It has to be equal. The sum of the two legs has got to equal the hypotenuse, and it's not equal. So just that simple. I just want yes or no answers when you see those, and go from there. Alright, so the rest of these are going to be about just like some word problems that you would see with the Pythagorean Theorem. If we have a rectangle, where's my rectangle? There we go. It has a length of 4 feet and a width of 10. Now you could put the 4 and the 10 anywhere you wanted to, but the 10 obviously would be there. And I always think of width as side to side. The width of something, like if somebody's got a wide behind, then that's side to side, right? Okay. So then up and down would be your length. All right, so we got 4 squared plus 10 squared. We have a 10. And then with the diagonal, that's what we're talking about. The diagonal is that piece that cuts across from opposite corner to opposite corner. So that's how we can end up using a lot of Pythagorean Theorem problems in different shapes, because you will be able to cut that and make it into a right triangle right in this region like that. Okay, so it'd be 4 squared plus 10 squared equals your x squared. That's not on the notice, but you see how it'd be set up from there. Alright, and that makes 10.8. And the hypotenuse should be longer. Think about it. Is it longer? Yeah, it's the longest side of that triangle. Alright, and so you got one like number 5, and I always put that on there because let's say we're going to Walmart and we want to buy the TV, and it says it's an 85-inch TV. It says on the big sign, 85-inch TV. Woo! What does that mean? 85-inch TV. A lot of people think it means 85 inches right there. Okay? That is not correct. It is not right there. When a TV gets advertised, the 85-inch TV means from opposite corner to opposite corner of the screen. Not the frame, just the screen, the glass part right there, or whatever they're made out of, now plastic, whatever. So, the height is 35, so that'll be on the side there. Why do they do that right there instead of on the width? Why do they put that there? That's supposed to be the biggest side, right? What do we as Americans like? The biggest and the best TV we can get, right? So that's going to sound a lot better when it's that number instead of whatever's right here. Okay? Not maybe a whole lot, but it's going to sound bigger. It is bigger. So setting it up, it would be 35 inches for the height, 35 and 85. So 35 squared plus whatever this width is right here, you can put a W if you like, squared equals your 85 squared. And so this makes 1225, the W squared, and 85 is 7225. Do we add the 1225 to the 7225? No. We're going to get it together, but we're going to subtract it. Subtract it to the other side. A little bit of algebra. So the width squared is 6,000, and square root. We'll take the square root of both. All right, so square root is 77.46, or rounded off to 0.5. So really, it's only 77.5 inches wide, which doesn't sound as good as 85 inches. Would you rather have a 77-inch TV or 85-inch TV? See? Same thing. So just wanted to show you that we have other shapes. We could have the, what you call it up in here? The Pythagorean Theorem. So isosceles, this is supposed to say trapezoid. I think I fixed it on your notes. An isosceles trapezoid has matching legs over here and here. So whatever I've got here, the 5 inches would match over here. And you get this little rectangle. When you draw your heights going down, you get a perfect little rectangle in the middle. So if I got 10 at the bottom, that rectangle is going to match. That'll be 10 from there to there. And then whatever these two pieces are on the side here, they're going to match. If it's isosceles, those two pieces will match. It'd be like you could fold it in half and everything matches. So you're thinking, what? But let's look for a triangle. We need to find the x's. We want to find the top base, this whole piece going across. Where do you see a triangle that you could figure out? Right here. Okay, that triangle has an x at the top, a 4 right there, and a 5 right there. Boom. So now you work it out. X ends up being 3 when you work that all the way out. So this is 3. This end down here will match it, 3. So what is the whole entire thing? 3 plus 3 plus 10, 16 would be that top base. Okay? That's kind of a mid-level, not the hardest problem on the ACT, kind of a medium-level problem right there. So not too bad once you know what you're talking about and what to look for. All right. Directions. A car drives 20 miles due east. Due east means straight to the east. Okay, and that would be like that, 20 miles straight to the east. And then 45 miles due south from there. So 45. How far is it back to the starting point? You see the right triangle? We're looking for what side? Hypotenuse. So 20 squared plus 45 squared would equal x squared. Same old stuff. Alright. End up with that. Alright. Square root. Triple. This is a little bit extra thrown in here. And this is something you can look up for an extra credit as well. A triple, they found triples are problems that work out perfectly. When we first started up at the very top where you had 6 and 8 on that right triangle, it worked out to 10. It wasn't a decimal. There's other sets of the 3 sides that come out perfectly without a decimal, and they're called a triple. So one of the first bases of the triple is a 3, 4, 5. So if a leg is 3 and a leg is 4, then the hypotenuse will be 5. That's a Pythagorean triple. It comes out perfect. So when you see that, and we kind of saw that with the trapezoid problem, 3, 4, 5, it'll come out automatic. And that's one they kind of expect you to know for the ACT. It's used a lot. So if the legs are 3 and 4, then you can just say, hey, I know this has got to be 5. It doesn't matter the order, but 5 has to be the hypotenuse. The biggest one has to be the hypotenuse. So if it's not, if you had something like 4 here and 5 here, and you're looking for the hypotenuse, then that's not going to work to be 3, because that wouldn't be the longest. All right, so you can do multiples of this. If you double all those numbers, say times 2, then you get 6, 8, and 10. And we did that with the very first problem. But you could also go back to the original and triple it, 3 times bigger. 3 times 3, 4 times 3, 5 times 3. This will work out to a perfect triple. And they'll come out, you won't have any decimals. You can keep going, times 4, times 5. And then keep on going with all these others. There's other bases, like there's a base that is 5, 12, and 13. And you can start there and double those and get them. So there's other combinations that could be used. I want you to look up for extra credit, okay, turn it in with your Google Classroom. Just send it to me and remind. Anytime you want to send me something special, send it to me and remind. Who were the first people to use Pythagorean triples? Now, it was a set of these numbers, these triple numbers, were found on a stone tablet. Not paper, stone. They carved it into stone. These carpenters used it for building buildings. Instead of saying, let's pull out the calculator. They didn't have that. Most of the carpenters didn't really have much school. They didn't go to school. They were trained on the job. As a little kid, they started toting bricks and stuff, and then they moved up to maybe, they let them have a hammer, and then they moved up to maybe planning stuff out. So they had this tablet that wrote down all these triples. So if I'm making a truss, I think that's what it's called. You ever go by and they're putting up a house. They got all these boards going straight up, and you got the roof, okay? But before you put the roof on, they got the boards out of that, of course, the ground down there. Do they just leave it like that? No, because it would fall over. The wind could blow those over. They could all just slide on over and turn into parallelograms and then turn into garbage because they would bend over like that. What they do is they put a piece in the middle that would be a supported beam. All right, and it stops that from bending, because that would change the size of your piece going across there. It would change your angles. So they would put those trusses in there. They would know that that's to support those pieces. How long, they wouldn't have to keep going and measuring and figuring out the calculations and all that. They just make the piece and it would fit if they measured it right. All right, so who were the first people? They are mentioned in the Bible. It is not the Israelites, it is not the Hebrews, it's nothing you guessed right off the top of your head. But if you know your Bible stories and you think back to some builders, you could probably figure it out. But it's Old Testament, and all you gotta do is look up Pythagorean triples, who were the first people to use it, and you ought to be able to get an easy extra credit. Remember, send it to me on Remind. Alright, so a couple of examples, and then I'll let you do your work. You've got your hexagon, and even though you're not quite familiar with it, these pieces would match. The 10 would match 10 over here, and then this 8 coming down would split whatever this side is in half. And we'll get to this when we study polygons later, but this side would match this side. Well, first you find your triangle, missing piece of the triangle, like right there. You got an 8 and a 10 and an X. If you think back to those triples, the 8 and the 10, the 6 would have gone with that. So that X would be 6. That means the other X is 6. That means this whole bottom piece would be 12. So every side of the hexagon would be 12 if it matched all the way around like that. Okay? I won't give you a test on that, but just know, that's where we're going with it. The whole bottom base of an isosceles triangle. This 9 is this up and down piece. I got 16 there, I got 16 there. Whatever's here is going to match over here. I just need to do Pythagorean theorem with one of these triangles and see what's missing for the X and then double it. So if I work it out with the X, it's going to end up being, let's see it on here, X squared plus 9 squared equals 16 squared, and X works out to 13.2. So the whole base, the whole bottom piece going all the way across, you double that and you're going to get 26.4. Okay. Now, you've got on your worksheet one of these circle problems, but it's a little different than this, but then I gave you an algebra problem that works like this. Let's do the algebra part first, and let's do it over here. So, a radius on your circle. Now, my little square kind of moved off, but that should have been at the center. The radius goes from the center to the edge. Remember that? All right, so this is a radius. So if that's a radius, what is this right here? That's also a radius. So if you just think about just that triangle, set up with Pythagorean theorem, it's going to be radius squared plus radius squared equals 20 squared. All right, leg, hypotenuse. Okay, now normally we say, well, you can't work this out because you're missing two sides, but they match, don't they? So r squared plus r squared. Think about this, r squared plus r squared. That's not r to the fourth, okay? What's in front of the r? Nothing, right? So what it means is a 1. 1r squared plus 1r squared equals 2r squared. So that's how you do that algebra. 20 squared is 400. We'll work that on out. Now, finish it up. You can't do any math here, so let's start getting rid of stuff. Easier to divide it first. Divide out the big 2. Divide out the big 2. And then radius squared is going to be 200. And you take the square root, just like we did on the other ones, and it's 14.4 for your radius. Your diameter will be twice, well, that's 1/4. Your diameter will be twice as big, so 28.28 or 28.3 if you rounded it up. 14 point, actually that works out to 2 when you round it, so 28.4 if you want to do it that way. Not 2, it's 1, sorry. That rounding is tricky, so I'm not going to worry about that. Now the one that's on your worksheet, I don't make you do it quite like that. I think like number 19 at the bottom is like this one, or number 20. Number 20 was like that, where you add the R's up, or you add up the legs just to match them. But the circle problem that's on yours, I think I asked you to find the whole diameter, but you got to find the radius first, and I think I gave you, not maybe that, but maybe we'll give you two sides. So it's not really that big of a deal on that one. So just do the Pythagorean theorem. I think I gave you something like maybe this is 8 and this is 10. You work it out, and then you got to remember to go back and make it into a diameter for the whole thing on the worksheet when you see that. So just try it, okay? I just want you to try. You can start and stop, rewatch this, parts of it, little guidance on it, and you'll have it. Good luck.